Okay, so let's get into DynamoDB. So DynamoDB is going to be a NoSQL database, fully managed, serverless, and can provide massive scale. It can go up to 1 million requests per second. It's going to have a similar architecture to Apache Cassandra, and users of Cassandra can migrate to DynamoDB, for example. There's no disk space to provision, and the max object size is going to be 400 kilobytes, and a way to store bigger objects into DynamoDB is to actually store the objects into Amazon S3 and store a reference to that object in DynamoDB. In terms of capacity, you have two modes. You have provision capacity, where you specify how many write capacity units and read capacity units, and if you want autoscaling on, or you can use on demand, where you're going to have to pay for every single write and read. This is better when you're going to have a more unexpected, unpredictable type of workload. So provision is going to give you the smoothest type of scaling and a better cost, whereas on-demand is going to be very helpful if you don't know your patterns in advance or you're doing some development, etc., etc. It supports CRUD, so create, read, update, delete, and the read can be eventually or strongly consistent, and it supports transactions across multiple tables, so it is possible to get ACID support with DynamoDB. You get backups available and point-in-time recovery. And finally, you have two table classes, standard for frequently accessed data and infrequent access for infrequently accessed data. So everything I said you should already know, but let's go back over the basics real quick. A DynamoDB is made of tables, and each table has primary keys that must be decided at creation time. Each table can have an infinite number of items, which are called rows, and each item will have attributes. They're like columns that can be added over time, and they can be null. As I said, an item cannot be bigger than 400 kilobytes. And in terms of data type supported, you have scalar, so string, number, binary, boolean, null. You get document types such as list, map, and you get set types such as string set, number set, and binary sets. Okay, primary key is more important. So option 1, you get just a partition key, and it's called a hash. And in this case, the partition key must be unique for each item. The whole idea behind the primary key is the uniqueness. And so the partition key must be diverse enough so that the data is going to be distributed. For example, if you have a users table, user ID is going to be a great partition key. So we'll have the partition key, and then we'll have a bunch of attributes such as first name and age. And this gives us the kind of users like this. So for John, there will be user ID, and for Katie, another user ID. And so this user ID is great. We only have one. It's unique. So it's a great choice for a partition key. The other option is to use a partition key that's going to be a primary key that's going to be composites. And so it's called a partition key plus a sort key. In which case, what must be unique is the combination of the two. So the partition key itself can be repeated as long as the sort key associated with it is going to be different every time. The data is going to be grouped logically on the tables by partition key. And it's also common to see the sort key being called a range key. For example, if you have users in games table, user ID would be great for the partition key, and game ID would be great for the sort key. So it's possible that a user has multiple games, but each game ID and user ID combination is going to be unique, hence is a great choice. Another good choice for a sort key is usually a timestamp. So you're trying to describe something that happens over time for a specific user ID, and so on, you will choose user ID for partition key, and you will choose a timestamp column for the sort key. So here's the example for user ID and game ID. We have the partition key and the sort key, and together as a composite key, they are unique, and the result can be some of the attributes. So again, here's an example. For this user ID 12 something 45, then there's two games that have been played. One was won and one was lost. And so we can see that the combination of the user ID and the game ID in this case is unique. Okay, hopefully all of this is not new to you. Then we have indexes. Object is made of a partition key, a sort key that is optional, and some attributes. And so we can define some indexes on top of it. So the first one is an LSI, or local secondary index. In this case, you need to make sure the primary key is kept, and you will just select an alternative sort key. And this LSI, or local secondary index, must be defined at table creation time. It cannot be defined afterwards. The other index you have is in case you want to change the primary key, then it's called a GSI for global secondary index. In this case, you can change the primary key, and you can also optionally have a sort key, and it can be defined after the table is created. So the idea in DynamoDB is that you can only query by primary key plus sort key on the main table and the indexes. So it's not like RDS where you can query any single column and any single rows. In DynamoDB, you need to think about what your queries are going to be and create the right indexes for these queries for it to work. So this is a major difference between a traditional RDBMS, such as RDS, and a NoSQL database, such as DynamoDB. In our case, in DynamoDB, if you want to query something, you need to make sure an index has been created for it in advance. Now, DynamoDB is a point of focus on the developer exam, little less on the Solutions Architect Pro, so you don't need to know all the details, but remember, between the LSI and the GSI, but remember that you need an index if you want to query a specific attribute in DynamoDB. Okay, so some important features of DynamoDB. Number one is TTL, which is to make a row expire after a specific amount of time. We have DynamoDB streams, where we want to react to changes to DynamoDB tables in real time. So this is a very common architecture. And this stream can be read by Lambda very commonly, or EC2. You get 24 hours retention of data in that stream. So here's a very common architecture. You have create, read, update, deletes are done to the table, and anything that modifies the table, so create, update, and delete, will be put into a DynamoDB stream. And that stream can be read by Lambda. And then from Lambda, you can, for example, put the data into Amazon OpenSearch, or Kinesis if you wanted to have some downstream, maybe Kinesis analytics application on top of it. So this is a very, very common solution architecture. We also have global tables, which is basically a table that is going to be replicated across all your regions. And this is active type of replication, so you can have many regions. And for this, you need to enable DynamoDB streams first. And it's very useful if you want to have low latency access to data into different regions, or you want to create a disaster recovery strategy that's going to have a very, very low RTO. So here's the example. We have two tables, one in US East 1 and the other one in AP Southeast 2. And whatever we do to the table on US East 1 is going to be replicated to the table in AP Southeast 2. And similarly, whatever we do in AP Southeast 2 is going to be replicated back into US East 1. Okay, you can use Kinesis data streams with DynamoDB streams. How does that work? Well, we know that DynamoDB streams will capture item level changes, but we can now send these changes directly into a desired Kinesis data stream. Why would you do that? Well, we only have 24 hours of data retention in DynamoDB streams, but with Kinesis data streams, we can get longer data retention period, up to 365 days. Also, we could use the Kinesis related tool suite to analyze the data. So how does that work? So DynamoDB tables will push item level changes in Kinesis data stream. And then we can use, for example, Kinesis data firehose to read this data and store it into the usual places. So Amazon S3, Redshift, or OpenSearch. Or you could use Kinesis data analytics to analyze this data in real time and do some real-time computation, such as some filtering, aggregation, transformation, and send that later on to Kinesis data streams, Kinesis data firehose, or Lambda. So now let's get into solution architecture. So we know that Amazon S3 is not a great way to search for objects because it doesn't have any indexing capabilities. And so what we want to do is store some metadata information into DynamoDB. So the way it works is that we will do writes to an Amazon S3 bucket to add objects or update objects. And we'll have a Lambda function being triggered by the S3 events. This Lambda function is going to take the metadata of the objects we're trying to insert into Amazon S3 and insert this into a DynamoDB table. And the cool thing about it is that now we can create an API to search for object metadata by creating the right indexes, the LSI and the GSI. So some things we can do thanks to this architecture is now we can say, okay, give me all the objects by date in Amazon S3, or give me the total amount of storage used by a certain customer, or give me all the objects that have a certain attribute. So by having these objects into S3 only, we could never answer this kind of queries. By having it into DynamoDB table, it becomes quite trivial. So finally, let's talk about caching in DynamoDB. So DAX, as you may know, is DynamoDB Accelerator, and it is a seamless cache for DynamoDB. You don't need to rewrite your application, and all the writes will go through DAX to DynamoDB. And what this gives you is microsecond latency for cached reads and queries, which is very handy. It solves the hotkey problem, so if there is in DynamoDB a specific row that is being read too many times because it is very popular, then you're going to get a throttling issue in DynamoDB, in which case creating a DAX cluster in front of DynamoDB is going to solve that problem for you by caching that row and making sure it does never reach DynamoDB. By default, your data is going to be cached for 5 minutes in your DAX, and there will be the TTL. Then the data will have to be refetched from DynamoDB. You can get up to 10 nodes in the cluster, and it can be multi-AZ, in which case AWS recommends you 3 nodes minimum for production. It's also secure. You get encryption at rest with KMS, VPC integration, IAM, collateral, and so on. and this is a default choice for a cache in DynamoDB. But we'll have a bit of a discussion into the right strategy right after. So the idea is your application wants to write to DynamoDB tables and read from them, and in the middle is going to be DAX, and it's going to be seamless for us, and it's going to cache the right rows and make sure we get the right performance where we need it. So the question is, from an architectural point of view, should you use DAX or ElastiCache for DynamoDB? So as a very simple problem, when you have your client who wants to directly access DynamoDB, then the right answer is to use DAX, because you will scan, have the individual objects being cached in DAX directly, and even the results of your query and your scan will be in DAX. But let's assume that your client, after retrieving a lot of the data, performs some heavy computation. And this computation can take, 10 seconds, 30 seconds. It can take a long time. Then you will want to be able to cache the results of these computations somewhere. And that somewhere may be ElastiCache. So for example, ElastiCache in this example could be a place where you want to store your aggregation results and make sure other clients can look into ElastiCache before getting the data into that from DynamoDB to get the aggregation results. So it is one kind of architecture. You could also swap ElastiCache for DynamoDB itself and have a table act as a cache. It is possible, but I want to show you here that DAX and ElastiCache can serve very different purposes. Okay, DAX is going to be for individual object cache and for query and scan caches in DynamoDB, whereas ElastiCache is for whatever you want to put in it. So it's very possible for you to perform some heavy computations and cache them centrally in ElastiCache to avoid going back to DAX and DynamoDB and do some expensive computations again. Okay, so that's it into DynamoDB. Remember it from an architectural point of view. This is all you need to know for the exam, and I will see you in the next lecture.